In this video, we are going to learn how to write a quadratic function in vertex form. So the instructions here say we need to write a quadratic function to model each of these graphs. But the way you start is first by identifying the vertex, since that makes up two of the variables in your vertex form. So the vertex, which is located here, is at 2, 5 for this problem. And right away, in my first step, I can rewrite my vertex form as x minus 2 squared plus 5. So I'm almost done. I just need to figure out what a is. Now I have two labeled points. Now a very common mistake could be to think that this is a slope going on here. But the slope is not up 4 over 2, which would be 2. It's actually something different, and we actually don't refer to this number as a slope. It's just a coefficient in front of our quadratic. So we need to figure out what a is, and the way you can figure this out is you can just take a point you see somewhere else, so in this case it would be at 4, 9, and plug that in for x and y, and all you'll be left with is a to solve for. So if I were to plug in 4 and 9, I would have 9 equals a times 4 minus 2 squared plus 5. And now I only have one variable left to solve for. So if we have 9 is equal to a times 2 squared plus 5. 9 is equal to 4a plus 5. We have 4 is now equal to 4a, so a is equal to 1. So what this tells me is that now that I know my vertex, which is 2, 5, and my a value, my answer is y is equal to an understood 1 times, because if a is 1, it's understood, x minus 2 squared plus 5. And that's how you can write a quadratic function in vertex form rather simply. You just need to figure out one variable by solving an equation. But let's try this again. We'll see here that our vertex is at the points -1, -3. So when I go to write this function of y is equal to a times x plus 1, because remember we have to subtract the 1. So it would be x minus -1, which is x plus 1, and then minus 3 on the outside. But now we have to figure out what this a value is, and we have a perfect candidate for a point up here, which is at 1, 5. So now I can plug in 5 for y, 1 for x, and solve for a. So we have 5 is equal to a times 2 squared, which gives me 5 is equal to a, or 4a, minus 3. We can add 3, giving me 8 is equal to 4a. With finishing this will give me a is equal to 2. So perfect. I now know that I just replace this a with a 2, and I'll have my function. So y is equal to 2 times x plus 1 squared minus 3. All right, last example is, so far these have all opened upwards and we've had a positive a value every time. But now when it opens downwards, we can actually get a prediction and think, okay, it's going to be a negative a value. And this also looks like a wider parabola. So perhaps it's a negative a value is less than 1. So like negative, like a third or a fourth possibly going on in this problem. So again, let's point out our vertex. which is at negative 4, 2. When I go to write my parabola, I'll have, I don't know what a is yet, so I'll just keep it as a. And I'll have x minus h, and this time I'll show you what happens with that negative, because it's x minus negative 4 squared plus 2. You'll see here that x minus negative 4 is just x plus 4, which makes sense. And these adding of a number on the inside does shift our parabola to the left, like you're seeing in both of these examples. So we'll have x plus 4 squared plus 2. But now we have to figure out what the a value is, and we have a good candidate down here on the left at 0, negative 6. Oh, sorry, at the right, bottom right. So 0, negative 6. So I'll have negative 6 for y and 0 for x. And now I have negative 6 equals a times 4 squared which is 16. So now I'll have negative 6 equals 16a plus 2. Subtract 2 from both sides gives me negative 8 equals 16a. And lastly, a is going to be equal to negative 1/2. So that does make sense. That's at less than 1 value. It's negative. It's pointing down. We can make predictions before we start doing the math. So our answer becomes negative 1/2. Again, just replacing the a in front of everything. Times x plus 4 squared plus 2. And that is how you write a quadratic equation in vertex form.